Hello, welcome to the first video on PCA. Let's get started. In this first video, we will take a first look at PCA, what it is, and see how it can be applied in an easy to understand example. PCA stands for Principal Components Analysis, and it does exactly that. PCA finds the principal components of data. What are principal components, you may ask? Well, principal components are the underlying structure of a specific dataset. It'll be easier if we take an example.
Here, the circles represent our data. We need to find the direction in which the variation is the greatest. In other words, we want to find the line where the data is the most spread once projected onto it. If we take this vertical line, you can see that the projection of the data is pretty near one another. However, if we take this horizontal line, you can see that the projection of the data is much more spread out. As a matter of fact, this is the line which has the largest variance. Hence, the horizontal line is the principal component of the data.
Now, let's take a look at a simple PCA applied to something we all like, famous French wines. So here we have a list of different wines. Each line is one wine. They correspond to the individuals of our universe. Each wine is categorized by 29 criteria, all graded from 0 to 5. Each column is one criteria. They represent the factors of our universe. So using a program like R, which if you don't have, we recommend you download it, it's free, we can perform a PCA on this set of data. For the sake of time, we will be using the Factomine R library in R in order to do our PCA. To import the matrix data, we use the function read.csv. We use the function library in order to import the package Factomine R. By doing so, we have the possibility of using all the functions of the library. To analyze the data, we need to transpose the data matrix. This is done with the T function. And finally, we use the PCA function in order to apply the method to the resulting matrix. A typical PCA program gives you the correlation circle. This circle shows you how the criterias, here the wines, are correlated to each other.
As you can see here, the taste criteria are correlated with the first principal component that corresponds to the horizontal axis, here the blue line, and the criteria of smell are correlated with the second principal component corresponding to the vertical axis, here the red line. Now, let's look at the placement of each wine according to the same principal components. With this graphic, we see the correlation between the wines and the criteria we saw previously. The interpretation we can have here is that the wines that are on top, here, 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 and here, are positively correlated with the criteria placed at the top of the correlation circle and negatively correlated to the criteria placed at the bottom of the circle. In general, the wines are positively or negatively correlated to the criteria depending on its placement in the graphic.
As we have seen in this video, the PCA method is pretty easy to implement using Excel or a program such as R. If you want to take a more manual approach, it will take hard coding, but we aren't afraid of challenges. Watch the next video to find out how you can construct your own PCA.